We are now in Vaxholm, right outside of Stockholm, and today I will show you. You know, people over here, they call it the Tesla boat. Yes, which is an electric boat, but it's a little bit special because it's hydrofoiling. So anyway, here we have Gustav. So okay, he's a little bit busy texting. Hi. Hey. So let me see. If I can just come on board? So, this is the Tesla boat. Right? People call it the Tesla boat.
Yeah, I've heard that before. Yeah.
So you're Gustav, right? From what is the company called Candela?
Well, the idea with the company name is basically that it's an SI unit, Candela, like Tesla is, so meter or kilo.
Yes.
So and it means sun intensity.
Yeah.
Light intensity.
Yeah,
actually.
exactly.
But I thought sort of all renewable energy sources come from the sun.
Yes.
And then the name must be Candela.
Brilliant. But can you show me the boat here?
Sure. Yeah.
Okay.
So the key idea with the whole boat is that we have it's a very light boat. So it's all boat built in carbon fiber, and if we combine that with hydrofoils that we've done here, meaning wings underneath the water, pushing the entire boat up from the surface, then you get a very low friction. Mm-hmm. And combining low weight and low friction, then you need very little energy to push the boat forward. So compared to a normal boat of this size, we need roughly 75% less energy. And then you get an electrical boat that has range and speed. And that has not really been possible before. And therefore the electrical boat market hasn't really taken off.
Cool. So can we see this one? So this is the motor, right?
Sure.
Yeah. So you open it to see.
Yeah, exactly. So it's a pretty standard electrical motor. It's liquid cooled, so you can make it fairly compact because an electrical motor, its size is very much driven by how much you can cool it. So if you cool it properly, you can make it smaller, and then it gets lighter.
And what kind of is it? Induction motor or what?
Yeah, so it's the opposite. It's a permanent magnet motor.
Okay.
So you have a permanent magnet rotor. And then you have the stator, the outside part of it, where you have the coils and so on.
Okay. And where does the battery sit?
The battery sits in the front. So we have a big hatch here.
Okay.
For that. And the key reason for putting it in front is that we want to have as long distance as possible between the front foil and the aft foil.
Okay.
And if you move the center of gravity forward, then you achieve that.
How can we see some of the hardware?
Well, that would take a while to open that hat, so we shouldn't do that today.
Okay,
So as a driver, I mean, despite being sort of a flying boat, so it's something in between a boat and an airplane, we have put pretty much effort in making it easy to use. So the only thing the user should be able to, or need to do, is to steer the boat and then to push the throttle.
Okay.
So in that sense, it's very much like a normal boat. And on top of that, we have developed our own user interface.
Whoa!
Yeah. So, and the key thinking here was that since we are so much into computer science anyway, we have some 95,000 lines of code in the boat to control the whole foil system. Then it was fairly easy for us to build also a user interface and integrate the maps and so on. So, and I've been in some motorboats before. My key impression from navigators is that they are extremely complicated to use. So the target was we should only have one screen where you should have all the information a user could possibly need. So it's the map, it's sort of your speed, the range, how much you have left of the battery. And then we did a little sort of thing. We wanted to indicate that this is partly an airplane. So you have this sort of airplane type indicator where you can see the pitch and the roll. So the horizon is always horizontal.
Well, cool. I think can we take a test ride in it?
Sure, we can do that.
Right, yeah. Right, this is the charge port, right?
Yeah, exactly. So we have no gasoline. Instead we have this and that. So you just need to plug that in. Exactly. Yeah. So it's the car standard that we're using.
Okay.
Then you just open this. It should all be watertight in a boat. So and then you plug it, and that's all you need to do.
So yeah. So can it fast charge?
Well, we are relying on normal electricity, meaning 230 volts and maximum 16 amps.
Okay.
And the reason for that is that there is no infrastructure in place today for fast charging, and we cannot sort of drive that.
Well, actually, that wouldn't work because the cable wouldn't reach you anyway. Yeah. So,
Yeah.
but how fast is the onboard charger then?
So we run 16 amps, 230 volts. That means if the battery is flat out, then you need like 12 hours to charge it.
Okay.
So you do it overnight, basically. So you run the boat during the day, and then you charge it overnight.
Yeah. Well, great.
Yeah.
And as you probably know, driving electric is dead silent. So right now we are moving already.
So now we're running 5 knots, and we are getting ready for a takeoff.
Takeoff.
Yes, and as an airplane, you need a lot of push to get the boat out of the water. So then that's when we need the most power. When we run at full speed, we need much less power than at takeoff. So that's really a boost that you need to give, and then we can reduce the power drastically. So you're going to feel that. The takeoff is pretty fast, and it becomes obvious when you get up in the air. So are you ready for takeoff? Okay,
Yes.
cool. Let's do that.
This is so weird.
Now we're up.
This is so weird. We're just flying through the wave. It's so smooth now.
Yeah.
What?
Yeah, that's except for being extremely efficient. We talked about 75% energy reduction. One of the key things with this boat is that it handles waves in a much better way than a normal boat. Today we don't have any wind waves, we just have waves from other boats, but it deals with wind waves in a fantastic way. It also deals with wind in a pretty cool way. So yeah, so now you might want to hold yourself tight, since we are crossing some waves here, and we might cut through. Well, we just manage as we did now. Yeah.
Wow. This is the first time for me and wifey riding a hydrofoil boat. The technology it's kind of old, right?
Yeah, the technology is super old. I think the oldest records are from 1860. There was a British scientist called Moy who he was actually experimenting with profile for airplane wings, and then to test them he put them in water, because then you needed much less speed than in an airplane than testing them in air. So and then he started to think maybe you can build a hydrofoil boat. And then in 1919, there was a guy called Alexander Graham Bell. He's not super famous for hydrofoils, but he built a hydrofoil boat that he tested on Lago di Maggiore in Italy.
Well, sorry to interrupt. What's happening now with the waves here?
Yeah, so we're gonna hit those waves. So we can manage pretty high waves.
Whoa. That's it?
Yeah.
Wow.
So Alexander Graham Bell, he developed it, and he was on hydrofoils. It was a bit of different technology than we use today, but it was still hydrofoils. And he did 64 knots with that boat, 1919. So exactly 100 years ago, at Lago di Maggiore. And I think that record held out for like 10 or 15 years in speed record for boats. So that's pretty cool. Yeah.
Oh, nice.
So now we're going to turn to the left, and one of the cool things with this boat is you can bank it pretty hard. So you can make, like an airplane, you sort of banking it inwards. So
That's cool.
You get the force down in the seat rather than sort of falling out to the side of the boat.
Wow. So to say, the ride is just super smooth. We just went over some waves now. You can see in the back there. Just flies right over it. This is amazing. Wow. I've been.
We can run it a bit faster.
Okay.
Yeah.
What's the speed now?
So now we're doing 27 knots.
27 knots. Okay.
You start to get a bit of sound from the wings.
Yeah. So we hear the propellers and the stuff.
Yeah.
The drivetrain is making noise.
Yeah.
So you can see here.
Yeah. So now we are hitting 30 knots, which is the.
Is this the number of kilowatt also?
Yeah.
So we're pulling 30 kilowatt to maintain speed for hydrofoiling.
Yeah. So I mean, if we're going to talk energy, the best is to run this boat at roughly 21 or 20 knots or something.
What? So now it's hydrofoiling?
Yes. But it's yeah, we're going to increase a bit to keep that speed.
15 kilowatt only.
Yeah. So now we are below 0.8 kilowatt hours per nautical mile, or around that.
What if? Okay.
And then we have 3 people on the boat.
Yeah. Wow.
Yeah.
What if we? How is the power draw if we're not hydrofoiling?
Well, I think to get to that number, 0.8,
Yeah.
which is like liters per kilometer,
Yeah.
but this is electricity, then you need to go down to 3 or 4 knots.
Well, can we go to the non-hydrofoiling state
Wanna land?
to see? Yes, land to see how the power consumption.
Yeah. You want to take your seat?
Okay, I'll just take my seat. Get ready. Going in for landing. We're landing. Okay, so
So now we're done.
wow, so that was landing. Okay.
Yeah.
All right. So can we see the difference in
Yeah.
efficiency?
Yeah, so let's see if we can find 0.8 and see what speed we can go at then.
Oh, really? And what?
Yeah, so yeah, we're doing 4 knots now. So this is typically how electrical boats are marketed. They give you a top speed, and then they give you the sort of the super slow speed
Yes.
or consumption. And then it sounds great. I mean, then you can get a consumption like a hydrofoil boat on paper.
Can you see if you slowly increase it until takeoff? What happens with the power and the...
Yeah, it will go up drastically.
Okay. Okay, so to push a lot of power.
Yeah, so now we are at this is roughly where you would have if this would not have foils, this would be the planing consumption. And now we need to push it a bit to get it to take off. So yeah, we get up to 4, almost 5 kilowatt hours per nautical mile.
And then, wow, suddenly, boom, the consumption goes down like crazy.
Yeah, and now I pull the throttle backwards. Otherwise, you get enormous acceleration when you get up.
Yeah.
Because the resistance just evaporates.
This is so fascinating. Wow.
So we go for landing again?
Yeah, okay.
Want to take a rear photo?
Okay, let me see. I'll go back here. So let's see when we land. Oof. That was super cool, man. Gustav, thank you so much.
Thank you. It was a pleasure to have you on board.
Yeah, so anyway, I think if you guys have any more questions, you can just comment. These guys, they're also on YouTube, so they can read the comment and answer them. Or you can try to find it on the website also. It's pretty cool, this one. Yeah, I like it. Thank you.
Thank you.